Resilience4J, which circuit is complete. The main dependency is this one. The state is now changed to open. Hello everyone, a very warm welcome to Think Constructive. I am Isha. In this session, I will be talking about Resilience4J, which comes from Spring Cloud family. And essentially, I'll be talking about how to make your microservices resilient with respect to Java Spring Boot microservices. All right. So here is the agenda for today's session. It is getting displayed on your screens right now. So in this session, I'll be covering all about Resilience4J, followed by CircuitBreaker pattern and the implementation, and further testing with variety of scenarios. So stay tuned. Don't leave the session in between. Otherwise, you might miss upon on some of the core concepts. All right. So let us quickly start with the Resilience4J discussion. So Resilience4J is a lightweight fault tolerance library that is designed for functional programming, specifically for functional programming, and it is supported from Java 8 onwards. It is introduced in Spring Cloud as a replacement of Hystrix. That means in the latest releases of Spring Cloud, Resilience4J is supported, whereas in the earlier releases of Spring Cloud, for the same purpose, that is for resiliency purpose, for fault tolerant purpose, Hystrix was there. Just to give you a little background, Hystrix was developed by Netflix and it was introduced in Spring Cloud. But now in the latest releases, Resilience4J is supported. Let's have a quick look on core modules of Resilience4J. So it provides a circuit breaker and its core module is Resilience4J circuit breaker. Another one is retry. Core module is Resilience4J retry. Then we have rate limiter, Resilience4J rate limiter. We also have bulkhead, that is Resilience4J bulkhead. Then time limiter, Resilience4J time limiter, and we also have cache module, that is Resilience4J cache module. In this session, we will be mainly focusing on circuit breaker, and with the help of circuit breaker, we will make our microservices fault tolerant. All right. So let's understand circuit breaker pattern. Circuit breaker is a design pattern which is commonly used in microservices architecture to handle the communication between different services. That means in microservices world, many services talk to each other, right? That means in order to get particular kind of data or particular kind of response, one service is dependent on another. That means if that service is not able to give response due to any reason, or that service is having issues, so what happens? Requesting service will not be able to get a proper response, or any response rather. In such kind of scenarios, circuit breaker comes into picture. What it does, it identifies that a particular service is having problem and it is unable to respond. So in that kind of scenario, requesting service, what it will do, it will do some kind of default processing, some kind of fallback mechanism, and return some response to the requester. Okay, so what is the goal of circuit breaker? It prevents the cascading failure of the entire system when one service instance is experiencing some issues. You can also think circuit breaker like an electricity circuit. When the circuit is complete or completely closed, so electricity is flowing seamlessly. But due to any reason, if that circuit is broken, electricity won't flow. Alright, so I hope this example will give you more clear picture. Okay, so what we can say? Fault tolerance is the property that enables the system to continue operating properly in the event of the failure of one or more faults within some of its components. Alright, and another key point for circuit breaker is it identifies the services which are not running and will execute the available fallback method. And the core module in terms of Resilience4J is Resilience4J hyphen circuit breaker. Okay, so in this session we'll be focusing more on the circuit breaker implementation. Now let us understand circuit breaker in little more detail with the help of our example microservices. Okay, so here is the example of our microservices. So just in case if you are not following our microservices previous sessions, here are the details getting displayed on your screen right now. I would highly recommend you go ahead and watch all those sessions. Those sessions are going to be extremely helpful for your microservices learning. Alright, so for now I'll just give you a quick recap of these services which we are implementing in our microservices session, and in this session we will make these services resilient. Alright, so in this example we have 3 microservices: user microservice, post microservice and notification microservice. Post microservice is responsible to get the post details for a particular post ID, and notification service is responsible to get the notification details for a particular notification. User microservice is taking user ID as an input and returning all the user details to the requester. In these user details, it is also collating post details as well as notification details. And from where is it getting? It is talking to post service to get all the post details, as well as it is talking to notification service to get all the notification detail. Alright, and finally it collates and return back to the requester. So that means my user service is talking to post service as well as notification service. So what happens if my post service goes down? User will query post service, but it won't get any response, or it might happen it is waiting endlessly. So what will happen to in such scenario to the requester? He'll endlessly waiting, isn't it? He's not getting any response. So what will be the better mechanism or better way to handle such kind of stuff? So when user service is unable to get any response from post service, it should do some default processing, some fallback kind of mechanism it should have in place, and should process the response and finally give the response back to the requester till the time post service is again back. Alright, this kind of implementation becomes very easy with the help of Resilience4J. Alright, so now let's have a look on the circuit breaker state machine. We'll understand this and then we will quickly start with the implementation. Alright, so here is the circuit breaker state machine. So as I told you that what happens in the electricity circuit, when the circuit is open, electricity doesn't flow. When the circuit is back to closed, electricity flows properly, smoothly, and the circuit is complete. The similar fundamental comes here. So you can see here in green box, closed. Closed means my circuit is complete and all services are able to communicate with each other seamlessly. So the terms here, what you are seeing, failure rate, threshold, half open, all these kind of terms and wait duration we will be defining in our implementation. So hold for a moment, first understand the concept and then I'll show you how to define all these parameters in our code. Okay, so let's say the calls which are coming to post service starts failing. So failure rate will start increasing, and the moment this failure rate will become greater than or equal to threshold, my circuit will become open. That means its state changes to open. Okay, whenever service is back, at least system should know. So in order to address that kind of issues, there is a concept of wait duration. After certain duration, whatever we are mentioning, configuring, so after that particular duration, the service state will be switched to half open. In half open state, service will again start getting calls, and if service is back to the normal state and it is able to process calls properly, that means its failure rate will start decreasing. That means it will become less than threshold and the services state will be back to closed. Okay. Another scenario is if the service is in half open state and the service is still not back to normal, still having issues, that means whatever calls will start coming to service, it will again start failing. So failure rate will start increasing again. So failure rate will become greater than or equal to threshold. So service will switch back from half open to open state, and again no calls will be entertained or no calls will go to service. Okay. So this is about circuit breaker state machine. Now let us start with the implementation of Resilience4J in our Java Spring Boot microservices. Okay, before that I'll quickly show you Resilience4J website also. So here is a Resilience4J website. You can notice resilience4j.readme.io/docs. Okay, so here complete Resilience4J introduction and detailing is written. Here you can notice the core modules of Resilience4J: circuit breaker, bulkhead, rate limiter, retry, time limiter and cache. Okay, so now let us start with the circuit breaker implementation with Resilience4J Spring Cloud. So for the entire implementation, I will be using IntelliJ IDE editor. You can use any other Java editor of your choice. Alright, as I mentioned that microservices series is ongoing, and in that we have already developed 3 microservices: user service, post service and notification service. So here all 3 microservices are shown, and just to reiterate, please go ahead and watch those sessions. Session details are again getting displayed on the screen. Links are tagged in the above card section as well as in the description box below. So please make full use of this series. Okay, so a quick recap about the implementation. User service is talking to post service as well as notification service. Okay, these are the 3 services, and user service is finally collecting all the responses from post service as well as notification service and giving the response back to the requester. Alright, so in our user service, here is a user controller, and you can notice it is querying post service as well as notification service. Fine. Now let's start making the changes in order to make the microservice resilient. Alright, so I'll start changing my pom.xml first for the user service, because user service is querying post and notification. So all the changes would go in user service. Alright, so in the user service, what I will do, I will include Resilience4J dependency, more specifically Resilience4J circuit breaker core module. Okay, AOP dependency, because that is needed in order to function it, and one more dependency, that is Actuator, that is another dependency which is needed to function it smoothly. Alright, so I'll just paste those 3 dependencies here. So you can notice we have a Spring Cloud starter, circuit breaker, Resilience4J. We have a Spring Boot starter AOP and a Spring Boot starter Actuator. All these 3 dependencies are needed. The main dependency is this one, the Resilience4J circuit breaker, and other 2 are needed in order to make its functionality smooth. Alright, so it is read. So what I need to do, I need to refresh my Maven dependencies. So dependencies are properly refreshed, and now you can see the error is gone. Fine. Alright, so that is one change. How will you get these dependencies? I will tag my Git link below in the description box. You can explore the Git repository. Also, there is one more method to do it, so I'll just show you that. So what you can do, you can open a Spring initializr, okay, get the required dependencies. So you will say Java Maven, because I am using Maven as a build tool, okay, and I will include dependencies here. So what I need, Resilience4J dependency, okay, another dependency I need Actuator, okay. So the dependencies I have taken, and I will just say explore. The moment you will say explore, you will be able to see this pom.xml here, and from here directly you can copy the required ones, okay, and also AOP. Fine, let us come back to the editor. So that's how you will include dependencies here. Another thing is, I will go to resources and will make changes in the application.properties or application.yaml. So for this demonstration, I am going to comment out my application.properties and create a file called application.yaml. Both files are fine, anyone you can use. So application.yaml is more easy to use, so I am going to put all the configurations there. Alright, so I'll just comment it, fine, and I will create a new file called application.yaml. Alright, and in this file I'll paste the required content and will explain you each one of them, okay. So what you can see here, server port, we are using 8082 port for our user service. Similar thing I have given here. I have also mentioned, you can see here, our service name and then the local default zone. So these are 3 are the older configuration, fine. So Spring application name user hyphen service and Eureka service URL we have mentioned as localhost 8999 Eureka. Fine, because my Eureka server is running here. This is something which we have covered in our previous sessions. So if you want to learn more about Eureka client, Eureka server, how to implement them, go ahead and watch that session. That will be very, very helpful for you. Alright, and from here management onwards, our circuit breaker Resilience4J configuration starts. Okay. So for circuit breaker health checkups, management health circuit breaker enable true. Okay. Endpoints web exposure will include health. This is for actuator, and endpoint health show details will be always. Okay. With the help of all this, we will be able to check the health of the services. Fine. So this is for actuator configuration. Now here is the Resilience4J circuit breaker configuration. So how should we do it? It will start from Resilience4J, then circuit breaker, then instances. So there can be many service instances you can register. I am doing it for user service. So I have given instances, and inside that my user service name. Exact name should match which we have given here. Okay. And we will be also specifying this name in our controller. Okay. So wait, I'll show you that. So now the next configuration is register health indicator true. Right. This is for actuator. So health indicator registration is important, mandatory. We'll mark it as true. Event consumer buffer size will be given as, we will be giving as 2. Failure rate threshold I am mentioning 60. So 60% failure rate threshold, as we discussed in our state machine. The moment failure rate threshold will be greater than or equal to threshold value, the state will be changed to open. So it is that minimum number of calls will be 6. Okay, automatic transition from open to half open enabled. So here you can see failure rate is greater than equal to threshold. It was that parameter. After wait duration, that means after certain waiting time from open to half open state will change, and in this half open state service will start taking the calls if it is back to normal. Otherwise again failure rate will be greater than equal to threshold, so it will go back to open. Fine. So the similar configuration, automatic transition from open to half open enabled, true. And what is the wait duration for that in open state? 3 seconds I have given. Although it is very, very high in the production, it's never 3 seconds, because you cannot keep waiting system for so long. It will be in nanoseconds. Okay, it will be so minimal, and services cannot be down for such a long period of time. Okay, so now the next thing, permitted number of calls in half open state. So remember, limited number of calls are allowed in half open state, so we have given it as 2. Okay, sliding window size is 10 and sliding window type is count based. So there are 2 types of sliding windows available in circuit breaker Resilience4J. One is count based, another one is time based. So I have taken count based, so I have given sliding window size as 10. Another is time based, so here you can mention time underscore based, and here duration can be given in that case. Alright, so this is another change in our code, and now we will come to user controller. Okay, and we will do the necessary changes here. So in our user controller, what I will do, I will first define my service name exactly as it is we have given in our application.yaml. So I'll first take a constant public static final string. Okay, and let's say I will say user. Okay, and here I will just paste the name as it is, so that there is no scope of any mistake. Fine. So I'll just paste it. Okay, so my user service name constant is defined. Now another important change what I'll be doing, I'll be writing here annotation circuit breaker. All right, and inside circuit breaker I'll be writing name is equal to my constant. That means the service name you should be mentioning. All right, and another important thing is parameter. What I'll be writing here is fallback method. It is already suggesting. Fine. And herein I should be giving a fallback method name. As it is method name, I should be writing here, which should be called in case of the service failure. Which service? Post or notification service failure. Alright. So let's say I'm writing user service fallback. Fine. A generic name I have created. You can be more specific as per your project's need. Alright. So what this fallback method will do, whenever my service, post or notification services are not responding, this method will be called. Alright. So let us define this method, then only it can be called, isn't it? So I will just say public, and what should be the return type? Its return type should match the return type of my get user. Alright. So I will just say user, okay, and the method name as it is I have pasted. And what will be the argument of this method? The argument will always be exception. Okay, I will, let's say, user exception. Okay, and I will give the method definition here, whatever I would want. So let's say for the example purposes, I will return something here. Okay, so I will just say return. Since it is returning user object, I need to construct that object here and will pass the required parameters. Okay, so user ID, username and user phone number, 3 things it is suggesting in my constructor. So I'll be writing that, let's say user ID 1. Okay, username I am giving as user 1. Okay, and I will just say phone number as XYZ. Fine. So what will happen if my post service is not responding? By default, this response will be returned. You can write any other response, whatever you want. So these are the necessary changes which were needed. So what we have done in the calling service, which is my user service, in our example, we have done 3 changes. We have included dependencies in pom.xml. Then we have included configuration in application.yaml. And we have made changes in user controller, the calling method. We annotated it with CircuitBreaker, and then we have written its fallback method. Alright. So all looks good. Fine. Let us now bring up our application. So first of all, I'll show you success scenario. So I'll bring up all 3 applications and we'll see a success scenario. And then as a next step, what we'll do, we will bring down our post service and we'll see how it behaves. Alright, so let me bring up user service application, then post service, so post service application, okay, and we will bring up our notification service application. So all 3 applications we can see are up, started, and user service is also started at port 8082. Fine. So now let us go to the browser window and we'll see. 8082 is our user service, and let's say I'll say /user/1. I'll just increase the size. Fine. So you can see user ID with all the required post details and notification details are there. Okay. Now let us see the actuator stuff. How is the health of this user application? Okay. I'll just say localhost 8082 /actuator /health. Cool. Yeah, my service is up. Okay, status up, circuit breaker status up, details of service status is up, no failure rate, threshold is defined as 60%. Okay, and buffered calls 1, state is closed. This is the important thing you should see. The state is closed. No issues. And you can see all 3 services are registered at Eureka. Cool, yeah? Now let us bring down the post and notification service, okay? And terminate both. Fine. Services are shut down, only user services up and running. Now let us go back to the browser window and refresh. Nothing is coming to post and notification. Fine. One more thing to notice here. You can notice this default fallback response. It is returning. Alright. When the service post and notifications are down, it is returning the default fallback response, whatever we have defined here. See, this is what we have defined in terms of fallback. So this is what is being called here. Okay. Now let us see the services health. So let us refresh this actuator and you can notice number of failed calls is 1. So now let us refresh it once more and you can notice failed calls 2, buffered calls 2. Alright. Now once more we'll refresh it, that is one more call. We'll again check the actuator health and this time failed calls 3. Now we'll refresh it once more, that is one more call, and we'll again check the actuator health and you can notice number of failed calls is 4. We'll again refresh it once more and you can again check the actuator health. Number of failed calls 5, status is still closed. Alright, and we'll again refresh it once more. We'll go back and check the actuator health and this time you can notice number of failed calls 6 and failure rate is 100%. And whereas my threshold is 60%. So state is now changed to open. So now let us wait for 3 seconds and I am just refreshing the actuator health. The state is changed to half open. Okay. That means it will take some calls. How many calls? 2 we have defined, right? You remember? I'll refresh it. Now refresh actuator. Failed calls 1, state is open because it can take 2. Okay. And remember, I have not bring up my applications. One more refresh and now failed call should be 2 and status is back to open again. Okay, because my services are not up and rate is 100%. Fine. So now I will go back to the editor and bring up the applications. Okay. So now you can see my application is up and running. Now let us go back to the browser window and let us refresh actuator health now. It is half open. Okay. Again the wait duration is over. So half open. Now let us refresh it. It's able to get the responses. Cool. Yeah. And now refresh the actuator. It is back to half open and there is no failed calls. Why? Because the call is successful. One more refresh. The status is changed to closed because the failure rate has become less or actually the 0 and the threshold is 60%. So it is able to take all the calls. The state is again closed. Right. Now I hope you have understood the circuit breaker pattern, Resilience4J configurations, uses and how you can make your microservices resilient. Alright, so what all we have covered in this session, we started with what is Resilience4J. We talked about core modules of Resilience4J, which was followed by understanding circuit breaker pattern in detail and the state machine or circuit breaker. Finally, we have implemented circuit breaker pattern with the help of Resilience4J, which is part of a Spring Cloud family, and we used it in our Java Spring Boot microservices and we tested it with the multiple scenarios. Alright, so I hope this session is very clear to all of you. If you have any doubts, feel free to write your doubts in the comment section below and I will try to get back to you as soon as possible. Thank you everyone for watching this session. I hope you found it useful. If so, hit the like button and subscribe to the channel, and also ring the notification bell so that you don't miss upon on any of the new upcoming videos on this channel. There are more sessions on microservices, Java Spring Boot and Java are available here. So subscription and ringing the notification bell will definitely help you. I hope you were following along with this session. That means you were coding with this session. If you haven't done so, I would highly recommend you go ahead and start coding along with the session, because that's how you will gain more confidence on building resilient microservices. Also, share the channel and session detail with your friends and family so that we grow together more stronger as a community. See you in the next session. Bye for now.